Last time I showed the inside of a Heathkit IG-28, a color bar and dot generator, something which makes test images with which you can align the picture of a TV set. Now, obviously I didn't want to bore you with the cleaning of it and all that, but to resume it in a nutshell, I checked the whole thing for obvious breaks or damages or whatever, and especially the three electrolytic capacitors you have right in the image right now. Since the appliance is probably, I'd say at least 30 years old. But what do you know, the electrolytics, they look fine. I didn't measure them, but I don't see any breaks or bursts or oozing liquid, so I think the capacitors are just fine. And by the way, right next on the left of the capacitors you see two 11 ohm 5 watt power resistors, which I checked the schematic, which are there to drop down the voltage a little bit. In any case, they look fine. All the other electrolytics I found inside, like this blue one, and two smaller ones, like the gray ones you see on this board, they look fine. I see no damage or wear or tear on them, so no, I'm not going to change them. The active components look fine too. Transistors, the integrated circuits, they all look just fine. As far as I can make out from the schematic, except for one integrated circuit which contains NAND gates or inverted AND gates, the others are all latched counters, which I presume are used to divide up a base frequency into a bunch of lower frequencies, which can be used to generate a video signal. Then there are three crystals. This is one. This is a 190 kilohertz crystal, and then there's a 4.5 and a 3.56 megahertz crystal. They both seem in good shape. I don't think there's anything wrong with them, so no, I'm not going to replace those either. Then I had a look at the underside. Let me show. I had a look at the underside of the function generator, and well, it wasn't too clean. There was a lot of solder paste, or rather leftovers, burnt leftovers from solder paste. I removed them with the help of a toothbrush and some alcohol, pure alcohol. And well, the printed circuit board looks just nice, just peachy. No breaks, no short circuits, etc., etc. I have to say though that the one who soldered all these parts, well, either he didn't have a very good solder iron, or he was in a real hurry to get all the parts onto the board, which makes really for a little bit of a a sloppy layout, but it's okay. I see no obvious breaks or anything, just a few wires that got singed, probably while the maker of this generator was soldering up parts. But the singeing is not too bad. I might replace this wire, but maybe I might not. Anyway, the next thing which is interesting on this piece of equipment is the transformer, and I'll tell you why. You see, this transformer has a dual secondary winding which generates 2 times 12 volts, I think. Let me have a look at the schematic. Where is my schematic here? Hang on. Alrighty, here's the schematic. Well, hang on, I'm reading the schematic. Aha! So, okay, so at the exit of the diode, I don't know if you can read this, but it says the output is 15 volts DC. So I suspect that the transformer has a 2 times 15 volts exit, or no, what am I saying? 2 times 7 volts and a half output, and it also has 4 input wires. Now, why is that? Well, I'll show you why. Normally this device is wired to run on 115 volts. Yeah, and it runs to the primary of this transformer, and this transformer has 2 primary coils. And the coils have pinouts numbered from 1 to 4, as you can see. Now, normally, if it's wired for 110, then the 2 primary coils are wired in parallel. However, if you want to run it on 220, then the 2 primary coils are wired in series. Now, the very first thing I realized is that I can wire this generator to run either on 110 or 220. Since I live in Europe, 220 obviously is more interesting to me, so that's what I'm going to do. I'm going to use this switch, which is a double-poled switch, which either connects these pins to the center pin or this pin to the center pin. And it's 2-poled, which means one side is for one pole, one side is for the other pole. And I'm going to wire this transformer so I can use the switch to switch it either between 220 and 110. How? Well, that's a little puzzle I leave up to you. Obviously, I solved the puzzle, and I'll tell you the secret of the puzzle, or I'll tell you the solution to the puzzle at the end of the next video. So, take your pens, take a piece of paper, and start drawing. How can I connect two primary coils on a transformer, either parallel or in series with one double pole 2-position switch? Get to your pens, fellas, and start drawing. You'll see the solution at the end of the next video. Oh, and by the way, I'll also mount a couple of fuse holders and fuses so that there's a fuse in the 220 circuit and in the 110 circuit. So for the ones of you who really like to draw a puzzle or to solve a puzzle, well, take into account the fuses too. We'll compare our results next time. Okay, goodbye for now.